Okay, welcome to the second module in the Robust Tools series. I'm now going to talk a little bit about how to get data into and out of R, and I'm going to talk about a few other little fundamental bits and pieces in the language that you kind of need to know about. So relative to the data visualization module that came before this and to the data manipulation module that's going to come afterwards, this one's going to be pretty short, I hope. So I'm going to use this as an opportunity because later on in the class I'm going to talk about how to write behavioral experiments in R, is to get started by thinking about data sets as they are often collected in behavioral sciences. So here is an example of a very simple study that I ran a couple of years ago, so not that long ago. This was joint work with Brett Hayes and various other people, and you can find the original paper by sort of clicking on the link here if you really wanted to, but I'll leave it to you. The experiment that I'm going to outline, you can go and run through yourself just by clicking on this link, and you can actually get a sense of what it was like for participants doing the experiment. But rather than waste your time, I'll give you a quick summary of how it works. The idea is that you're pretending it's the future, and you've got a pilot, a robot probe that's been sent to explore this alien planet of Sodor. I know, right? Exciting. And you're given one of two stories about what we're doing. We're looking for plaxium rocks, so rocks that are covered with this weird, valuable thingy called plaxium. And in one condition of the experiment, what participants are told is that the drone comes with this little camera attached to it, and it can take, and it's a plaxium-sensitive camera. So every time it encounters a rock that has plaxium on it, it takes a photo, and you get sent those photos. So what you get sent is images of rocks that do have plaxium as sampled, as encountered by the robot. In the other condition, you're told, well, actually the drone has can pick up it has a little claw thing in it, and it can pick up rocks, but only the small rocks, and it can test them to see if they're positive or negative in plaxium. So the key thing here is that it's possible to see rocks that have to get data about rocks that do have plaxium and rocks that don't have plaxium, but you can only get small rocks, so it's impossible to get large rocks in this condition. So both of these experimental conditions involve some degree of censoring. In the first condition, in property sampling, it's impossible for the robot to collect data on rocks that don't have plaxium, because plaxium is what the camera's built to detect. In the second condition, in category sampling, the robot is limited to collecting small rocks. So large rocks are impossible, but you can see plaxium positive rocks and plaxium negative rocks. So then the participant is, hello, please move on, there we go. So is then shown the results, right? So they send the drone out to the planet of Sodor, and you see, here's a couple of small rocks that have plaxium. And after two judgments, you've got to make some generalizations about whether or not newly encountered rocks of different sizes will or won't have plaxium. You then show them a few more observations that are also small rocks that have plaxium, and you've shown more observations. After each sample size, you repeat those judgments. And what those judgments are is you are shown rocks that vary from very, very small to very, very large, and in each case you've got to rate how likely is it, do you think, that rocks of this size can have plaxium on them, right? In both conditions, the only thing the participant has ever seen is small rocks that have plaxium. But because they've been collected by different mechanisms, you might choose to reason differently about how likely things are. And to cut a long story short, here's what the data from our experiment look like. So we've got a situation where each of these panels plots the distribution of participant responses. So it's got a median there, that's the thick bar, and the interquartile range, which is the box. These are box plots without the whiskers attached to them. And this is for, on the left, you've got test item 1, that's very, very small rocks, all the way up to test item 7, that's your very, very large rocks. So in every condition, regardless of sample size, people think that small rocks are more likely to have plaxium than large. That makes sense because the only thing you've ever seen are small rocks with plaxium on them. The question that we have is what happens as a consequence of this sampling mechanism. So if you know that it's in a category sampling condition, that all you could ever have seen are small rocks, seeing more and more small rocks doesn't make you change your opinions about large rocks. Fact is, like the yellow bars as you go from top to bottom on the left hand side just don't change very much. In contrast, in the property sampling condition, where you can only see plaxium positive rocks, but they can be small or large, but all you've actually seen are small rocks, then you get suspicious. If by 12, so by the time you've seen 12 observations, so this is the bottom right panel here, and every single one of them has been a small rock with plaxium on it, you start becoming convinced, okay, it's impossible for large rocks to have plaxium on them because I should have seen one by now. And so that's what you see in the property sampling condition. You see a change from top to bottom. That's the core result for the experiments. That's what our study was all about. And that's the data that we're going to play around with in this section and in later sections of the class. Okay, so when I was doing this, for my undergrad class, I would say at this point, okay, let's have a quick discussion about this study, see that you understand it, do you feel confident that you get what it's about, and so on. I'll hope that it's made sense to you in this little video, and I'll kind of move on to the very, very first job that we have to do from an R point of view, which is we need to read the data. We need to get it into R in some fashion. So to do that, we're going to do our usual thing of working in an RStudio Cloud project. And so here you can click on this link, or we can do what I've done, and here's one I loaded earlier. Hello. You can see, I'll just point out over here that in the files pane, so I've set mine so that the files pane is up here on the top right because my face is on your screen and I don't want it getting in the way of things, but normally the files pane would be down here on the bottom right. Okay. Anyway, this data underscore reasoning.csv file is where our data set is stored, and we're going to want to load that into R. So unlike the MPG data set, this doesn't come bundled with any R packages. I mean, why would it? It's something that I created. So you're going to have to get it into R and do something with it. So let's go back, and hopefully the slides will tell me how to do it. I did write them, so I'm hoping they will. Okay, so as always, remember we're doing all of this stuff using a tidyverse approach. So if we were writing a script to do this, we would make sure that the first thing we do is load the tidyverse, yes, that'll work. No, the tidyverse using the library function. And then all you have to do to load it is use this function called read_cv. And all you need to do there is pass it, again using the technical term here, one argument. All we really need, which has a name of file, and you just tell it the path to the file you want to open. So in this project, because everything is all nice and neat in the one project folder, we can just say, the file is data underscore reasoning .csv. So let's go and do that ourselves and see what happens. So I've got my little open script here. We'll go, all right, do my usual thing. This is a script for the hello data. Hello? Yeah, that'll do. Okay, and then I would say author, Danielle. I want you to, as a general rule, get into the habit of documenting things as you go. So we'll go, okay, load packages, library, tidyverse. Yeah, I can even spell, that's good. Okay, and then we're going to go read the data, and that's going to be, so we'll say the frames, and that's, this is the assignment operator, as we've seen before, often pronounced get. So I'll say frames gets read underscore CSV, and then I'm going to go file equals, what did I say that it was? It was going to be data underscore, and I've just hit tab there to bring up some options, and it's going to give, it's trying to guess what the relevant files might be. In this case we want data reasoning, so that'll do. So we'll go Control S to save, and we'll go, I'm going to call mine blah, okay, no, I won't call it blah, I should be better than that. We'll call this hello data script. It's really boring, but generally giving all of your things some kind of meaningful file name is generally good practice, even if you're doing it for the sake of a demo. So I'll try to be good. Okay, so we've saved the script. Now we go source, so I can either just click on that, or if I use a shortcut key, it's Control Shift S, and it takes a second, and we watch the output, and it goes, okay, we're attaching all of our library tidyverse stuff, and that's, so all the stuff here is, yep, that's loaded tidyverse. This part here, the output, this isn't an output, this is a message. So what that is read CSV is telling you what it thinks it's just loaded. So instead of trying to do this on the tiny screen, if I tab back over here, aha, I was smart enough to include it in my slides. Every now and then I actually know what I'm doing. Every now and then, not often. Okay, so what to look at here is we're saying, okay, this has been parsed with column specification. So parsed here just means we've read it. With column specification means what it's doing is it's looking through my CSV file, a comma separated value file, and is going through column by column, and it's trying to guess what kind of variable is in each column. So what it said is that in the first column, it's gone, okay, we've got a variable that we're going to call ID, and its ID equals col double is a slightly roundabout way of saying that R thinks that this is a numeric variable. Double, which is short for double precision floating point integer, which honestly you don't need to care about if you're taking my class, but if you know what these things are, then yes, it's double precision. No, R doesn't have single. Anyway, moving on. Gender, which is going to be just it's just free text, and what you can see when looking at the gender is it's guessed that gender is character. Age is a number, condition is a character, sample size is character, because that's going, well, you'll see it in a second, but that's the data variable, that's the one that says, is this small, medium, or large? The number of observations that made up the sample size, this is the number of rocks the participant had seen, not the number of people in my experiment. That's numeric. Test item, that's that number from 1 to 7 that indicates whether or not it was a rock of small size at 1, large at 7, that's a numeric variable. Response, that's the participant's actual response in the experiment, and that is numeric as well. So that's col double, meaning that it is, you know, a numeric beastie. Okay, so yes, we can now have a look at our data, right? I wanted you to understand that much just because it is useful to know what your output is or what you're seeing when you run this command. But realistically, in most circumstances, probably the first thing you'll want to do is just go tab over here to the environment pane, and you'll see that we have here, it says data, there is frames, and frames is a tibble, or data frame with 4,775 observations and 8 variables. So if I just click on it, R brings me up this kind of pretty looking spreadsheet style thing where I can go, okay, yep, there's the ID, gender, age, condition, etc. You can't edit this, like it's not meant to be editable like a spreadsheet or anything, it's just there for your visual convenience. You can get the same kind of results if I'll just bring that, Control L to clear my screen. If I just type frames at the console, you can see you get the same thing in just slightly less pretty form. So it's going to, a tibble tells you how big it is, there's the names of the variables up the top, and there's the number of the rows at the bottom. Okay, so now we've got our data loaded into R, and we can start doing things with it. This is just me showing you in the slides the same thing that I just showed on screen. If you wanted to be super explicit, so where I just typed frames before at the console, if you want to be super explicit and really make sure that R prints it, you can type print frames. That will do the same thing, and you get, there you go, that's the output. Another type of thing that you may find yourself wanting to do from time to time is glimpsing the data. To give you a sense of how these two things differ from each other, I'll type it over here and go glimpse, glimpy, glimpse, frames, F frame, yeah, that really helped. Glimpse, frames, please. There we go. This gives you, again, it's the same information, but instead of showing you it as a table where each of the rows is like, the rows are rows and the columns are columns, what it's done instead is kind of flip it on its side and kind of gone, okay, there are 4,700 observations with 8 variables, and then it's just listed them in that order there. Sometimes this view is useful. Sometimes I just print things, sometimes you may want to glimpse them. Either works really, just useful to know about those two versions. Okay, and I will stop this one here. There's an exercise over in, if we go back, cut over here, look over in the files pane. Hey, there's an exercise, hello O2, the script here that you can go through, and it's another one of those emoji replacement exercises to get things up and running, and using the forensic data set rather than the reasoning data set. So the exercises here will tend to use the do-it-yourself exercises use forensic, the ones that I'm going through here in slides use reasoning. That's kind of a deliberate thing in my classroom so that you have a bit of a, you can type along with me with the reasoning, and then when you do it yourself you can see if you've learned the whole thing by seeing if you can generalize the skills to the forensic data set. Alright, but that's it. I will be back in the next video. Alright, stop.